Hi guys. Today we're continuing with slope, otherwise known as the rate of change. Today we're going to be focusing on a different type of problem. So yesterday I gave you a graph and you had to find the slope of the line. Today we're going to be focusing on finding slope given a table of ordered pairs. Don't forget that slope should always be written as a fraction. It's a comparison of the change in your letter y's and the change in your letter x's. So again, having that fraction, having the two numbers is very important so that we know how much is the y changing and how much is the x changing. Take a minute right now to copy this chart into your notes. This is called a T-chart or an XY table. In this problem, I did give you a context for the numbers. So my first column is time measured in minutes, and my second column is distance measured in feet. Since we're looking at the change in x and y, what we'll be doing is we'll be comparing the first row with the second row and asking ourselves, using only adding and subtracting, how can I get from the first row to the second row? So if I'm looking at my x numbers to get from 1 to 2, I would add 1. Next, we'll be looking at the change from the second row to the third row. So you do want to look at the change for the entire chart and make sure that it's staying consistent. So to get from 2 to 3, I would also add 1. And we do need to check that last one as well. So I'm going to check from 3 to 4, and that one is also adding 1. Now, it's not always going to happen that way, but we are starting with a basic example. So in this example, all of my change in my x was by adding 1. Next, let's check for the change in the y, which would be the second column. Now, if you can't figure this out off the top of your head, what you can always do is you can just take the second number minus the first number. So in a calculator, you can do 520 minus 260, and that tells you that this is an increase of 260. So 260 plus 260 will give me 520. Now, don't just assume that they're all going to be the same. You do need to actually check and calculate to see if they are all the same. So for the next one, again, in my calculator, I would do 780 minus 520. And I do get 260 again. And then again, can't assume on that last one either. So I'm going to check in my calculator one last time. 1040 minus 780, and that also gives me 260. So I feel pretty confident that this has a constant rate of change, that this has a consistent slope. I do want to make sure that I'm writing the slope in the correct way. So again, if we look up here at our fraction, it's the change in the y on top and the change in the x on the bottom. And just like our ordered pairs, the first number is x and the second number is y. So when I'm setting up my slope with my fraction, I'm going to take my second number, my 260, and I'm going to put it on top of my first number, 1. I am going to set up 3 fractions because I do need to make sure that all of the fractions are equivalent, that they're all equal. And in this problem, it was pretty obvious, but it's not always obvious if they're equal or not. After I've set up my change in my y over my change in my x, and I have confirmed that all the fractions are equal, I can now confidently say that this table has a constant rate of change, and that rate of change is 260 over 1. Remember, you still need two numbers. You need your fraction. Yesterday, we talked about rise over run, and so if you don't have that bottom number, we won't remember what the run is. Let's take a look at another table. Make sure to pause the video and copy the table into your notes before we start working on it. I'm going to start again with the first column, which is my x's. And so to get from the first number to the second number from 20 to 40, I needed to add 20. To get from 40 to 60, I also needed to add 20. And to get from 60 to 100, this time I needed to add 40. Now, that does not automatically make this problem not have a constant rate of change. It's actually okay if all of your increases are not the same number. What we're going to do is we're going to set up fractions, and if all the fractions can simplify to the same number, then we're going to say, yep, this has a constant rate of change. So it's okay that these are not all the same number. Coming over to my y numbers, to get from 30 to 35, I need to add 5. To get from 35 to 60, I need to add 25. And to get from 60 to 70, I need to add 10. Now I'm starting to get a little bit worried here because these first two numbers were the same for my x's, but they're not the same for my y's. But let's just kind of see where this takes us. Remember, when you're setting up your slope, your rate of change, the y number goes on top and the x number goes on the bottom. So for my first fraction, I'm going to put 5 over 20. My second fraction will be 25 over 20. And my third fraction will be 10 over 40. Now, obviously, these are not all the same fractions, but I do want to simplify them. Sometimes when you simplify them, they do all turn into the same fractions. So my first fraction will simplify to 1 over 4. My last fraction actually also simplifies to 1 over 4. So this 20 and this 40 actually both simplify to 1 over 4. So again, it's okay if you're not getting the same numbers here. That middle fraction, though, that's going to kind of screw me up a little bit because that's going to simplify to 5 over 4, which is not the same as the other fractions. So it's actually these middle numbers, this middle change, this middle jump that makes this not have a constant rate of change. Basically what that means is if I graphed all of these ordered pairs, I could not connect them to make a straight line. It would make kind of like a zigzag line. And so this does not have a constant rate of change. It's not linear. It does not make a nice straight line. And so based on what the question says, we would just say the word, nope, it does not have a constant rate of change. And therefore, I cannot tell you what the rate of change is because it's not consistent. So sometimes these tables, they don't work out. Sometimes they don't give us a constant rate of change. That's also why you have to check all the numbers. You can't just check the first one and say, yep, the answer is 1 over 4. You have to make sure that they're all consistent. Let's try one more just for good measure, and then we'll be done for today's notes. Okay, so again, pause the video, copy this table down into your notes. When you're doing your homework, you also want to copy the table into your notes so that you're able to write down what that change is, just like we're doing on the PowerPoint. And let's get started. So to get from 1 to 4, I'm going to add 3. To get from 4 to 7, I'm also going to add 3. And to get from 7 to 12, I'm not adding 3, this time I'm adding 5. But as we learned on the previous problem, it's okay if these are not all the same number. It's all about setting up the fraction and simplifying the fraction. Checking my y numbers, to get from 0.25 to 1, I have to add 0.75. To get from 1 to 1.75, I also have to add 0.75. That's a good sign so far, because now I have 0.75 and 3 and 0.75 and 3. So those numbers matching together, that's a good sign. Now for the last one, I shouldn't get 0.75 again because my last number was not 3, it was 5. In fact, since 5 is bigger than 3, I'm expecting to get a number bigger than 0.75 over here. And I get 1.25. Now, before we can say anything confidently, we're going to set up our fractions. Our y numbers go on top and our x numbers go on the bottom. So 0.75 over 3, 0.75 over 3 again, those are obviously equivalent, and then 1.25 over 5. Now in this problem, I'm not going to simplify my fraction since it contains a decimal. I'm just going to straight up divide in my calculator. So 0.75 divided by 3 in my calculator gives me 0.25, and that's for the first two fractions. So I just need to check that third one. And 1.25 divided by 5 in my calculator also gives me 0.25. And so since all three fractions simplify to the same number, I'm going to say, yes, this has a constant rate of change. This has a slope. If I graph these ordered pairs, they would connect and make a nice straight line. And the slope of that line, now we're not going to write 0.25 because that doesn't give me a rise and a run. So I need to write the fraction equivalent of 0.25. And the fraction equivalent of 0.25 is 1 over 4. So this problem, I say, yes, it does have a constant rate of change, and that rate of change is 1 over 4. So make sure that you're showing this amount of work on your homework tonight. You should be copying down the table, and you should be finding the change from each row to the next, not just the first ones. And then I'd love to see some fractions as well. This concludes today's notes.